I thought I use Firestore serverless functions for backend. Why does Next.js provide server functions for my SPA? Because Next.js is both a front-end framework and an optional backend runtime. Serverless functions Firebase, server actions, or APA routes Next.js. They overlap in capabilities. You don't need both, but you can combine them. Why Next.js still provides backend features? Even if you plan to use only Firebase functions, Next.js doesn't know that. It offers Next.js server feature app slash API or API routes, purpose handle request close to the UI. So Next.js doesn't know that you only plan to use the Firebase functions. The app/API you have routes in LiveKit handles requests close to the UI or close to the React server components. It fetch data on the server. Server actions mutate data from the server. Mutate DB from the server. So that's what retrieves your DB to the server. Middleware, auth, or redirects. These exist because many apps do not need an external backend at all. But your LiveKit plus Firestore app does need one, which is Firebase functions. That's the reason why you need to implement the Next.js, because your app needs an external backend and many apps doesn't need to. Best practice for your telehealth app: task, AI summaries, best location, Firebase functions. Task, secure access control, best location, Firebase functions plus auth rules. Task, WebRTC signaling events, Firebase functions, LiveKit webhooks. Task, UI fetching, public cache data. Next.js server components. So Next.js are better to handle the UI fetching and caching the UI and the public data. Video calls, best location, LiveKit SFU, not Next.js, not Firebase, but the actual LiveKit way to deploy the app. So your real architecture is React UI, Next.js SPA, single page application, which fetch and cache to Firestore over UDP slash gRPC over HTTP slash 2. Then it will send events to Firebase functions. So you send to Firestore first before Firebase function, which is the serverless, and then signaling hooks to LiveKit SFU, UDP slash quick for media. Sorry, for Firestore, you actually use TCP instead of UDP. You only use UDP at the end on LiveKit. Full architecture plus packet flow requested. Telehealth video system. LiveKit plus Next.js plus Firestore. Patient browser. React plus Next.js plus IndexedDB plus service worker. WebRTC media. So it will signal WebSocket TCP HTTP slash 2 to Firestore, and then Firestore with its gRPC HTTP slash 2 document reads or write TCP will fetch back TCP to the patient browser. Now, the Firestore, the front end will cache JSON, IndexedDB, and Blob Plus from Firestore. And then the Firestore will send uploads, HTTPS, and TCP response for the successful upload. And then the Firestore will do the function call to Firebase functions, which has the AI summary, access checks, and the security we discussed, and webhook auth. And then the Firebase functions will reply with a webhook event to Firestore. And then the Firebase functions will trigger a webhook event as well to LiveKit SFU. And then the LiveKit will reply with REST API auth via TCP. And then you connect to LiveKit via UDP and quick. WebRTC media flow, media type, video frames, protocol RTP over UDP, transport DTLS SRTP, notes, real-time packet loss OK. Media type audio, protocol RTP over UDP, transport DTLS to SRTP, notes same as above. Turn relay NAT, protocol UDP to TCP fallback, transport TCP or TLS, only when blocked by CGNAT, which is often blocked. Signaling, WebSocket, TCP only, its control channel. So flow, camera to WebRTC to RTP packets. So the camera is actually what triggers the WebRTC, then WebRTC trigger the RTP packets, or usually UDP, then LiveKit SFU, the one we discussed in TCP, to UDP to remote browser. Firestore never carries video. Only WebRTC metadata and text goes through that flow. Now browser memory plus index TP plus TCP visualize. So JavaScript, if we have patient record, JSON parse to objects. Now that objects JSON will be converted to JSON text. It will fetch in TCP packets, HTTP buffer / TCP receive, 850 to 20. 850 to 2 to 20 kilobytes Firestore docs. So that's what you sent from front end to via HTTP or TCP packets, JSON text, HTTP buffer, TCP received by Firestore docs. Then disk cache. So you cache this into the disk in Firestore that became an index DP. Offline caching, binary blobs. So why store consult history in index DB? Offline doctor access. Instant reload. Reduces Firestore reads. Can export encrypted backups. So you can also implement this by caching everything in IndexedDB or in this cache of the Firestore, and then letting the doctor access the consultation record offline. Final key idea, Firestore equals TCP document transport, LiveKit equal UDP / quick media transport, Next.js server equal optional but close to the UI. Firebase functions equal real backend for business logic. Why does your LiveKit webhook run inside app/API if you already have Firebase functions? That's a good question, because you decided to put it there. Nothing is interfering. You simply wrote the webhook handler in next.js, not in Firebase functions. You could move it to Firebase functions, but currently your architecture is feature WebRTC media, who handles it, LiveKit SFU, feature real-time signaling, who handles it, LiveKit plus browser, feature storing calls / transcriptions plus AI summary, Next.js API routes calling Firebase admin SDK. So that's actually how you store the calls and the AI summary, by having Next.js API call the Firebase admin SDK. DB reads or writes. Firebase admin inside Next.js. So this is actually how you write in your DB using Firebase admin inside Next.js. So Next.js are responsible for writing that AI summaries and call transcription. So the webhook event that's being triggered by your business logic that could be in the Firebase function are actually being triggered by Next.js. Auth rules and Firestore security. Firestore or Firebase auth. So that's what handle the security. SPA UI, Next.js client components. So the SPA UI, the one responsible for that is your Next.js client components. Your backend is not Firebase functions. Your backend is Next.js with Firebase admin. So React doesn't make your backend disappear. React is not equal to backend. LiveKit is not equal to backend. Firestore is not equal to backend. Your true backend logic lives where Firebase admin runs. Right now, Firebase admin runs in your Next.js API route, like import get Firebase admin from lib slash Firebase dash admin semicolon. That means you're running a secure server code inside Next.js, not Firebase functions. AI summary generation is done inside Next.js, not Firebase functions. So you are running secure server code inside Next.js, not Firebase functions. AI summary generation is done inside Next.js, not Firebase functions. That's actually where the summary happen inside Next.js. That's why it's kind of like in the browser that translate it and then send it to Firebase or Firestore immediately. Webhook validation is executed inside Next.js, not Firebase function. So the webhook are being triggered inside Next.js. Next.js is your acting as your backend runtime. So it's the one that's running your backend logic. It's also why it's directly connected to your Vercel. Why you are confused? You thought that by using Firebase, you had front-end React to Firebase backend. But what you really built is front-end React to Next.js backend to Firebase database. So you just use the Firebase as a database. This is a very valid architecture, but you must understand what it means. But doesn't Next.js conflict with Firebase functions? No, it only conflicts if you deploy both to receive the same webhook. Because now you have to worry about synchronizing those if you have those two webhook. Currently, LiveKit sends webhook to your deployed Next.js URL. So that's what triggers LiveKit that allows you to know or to signal or to communicate to LiveKit and then connect it back to the Firebase database. Firebase functions does not receive anything. Nothing is overlapping. There's no conflict. Firestore is just a database. Both platforms can write to it. So whether it's Next.js or Firebase function can write to a Firestore. Only one platform does. In your case, Next.js is the only writer for summaries. Firebase function is not being used for webhook or AI. So the Firebase functions is not being used for LiveKit. It's one of your main driver or feature, and for AI, it's actually Next.js. Key concept, a webhook goes to whichever backend you point to. Just like a delivery driver brings food where you send the address. You pointed LiveKit webhook here, API slash LiveKit slash webhook. That's a Next.js address. So of course, Next.js receives it, not Firebase functions. To make Firebase functions handle it, you would change the address. And also, some part of your app is actually React, such as the front end. It's bundled by HTML. So a lot of part of your application is actually being handled by Next.js, especially the cores like LiveKit and the AI. So what does use client have to do with this? Nothing. You thought if I mark component as use client, then I'm not using backend features. No, use client only disables rendering on the server. It has zero relation to API routes. So just because you didn't use clients doesn't mean you didn't use the Next.js as a backend. Your rendering can be client-side. Backend logic can still live on Next.js. So your system is client rendered UI plus server backend API. Final clear summary, layer, video, who handles it, LiveKit. Layer, transcription plus summary, who handles it, Next.js API routes. Layer, database, who handles it, Firestore. Layer, authentication rules, who handles it, Firebase Auth. Layer, front end, who handles it, React, Next.js client components, but it's mainly React SSR. You disabled it with use client. Server logic still exists in Next.js API routes. You do not need Firebase functions unless you want to move backend logic away from Next.js. Right now, Next.js is your backend. One sentence answer. Your LiveKit webhook plus AI summary runs in a Next.js API route because you wrote it there, and Next.js is acting as your backend even though your UI is client rendered. So this Next.js API is kind of like your backend logic and full stack blogging app. So it's not MongoDB, it's a React, kind of like a React backend, but mostly it's still a JavaScript. First, no SSR does not mean Next.js runs on the client. There are two independent parts of Next.js. Part client components runs on browser, React, purpose UI. So Next.js could be a separate component, but still the same Next.js. Another component is API routes / server components. It runs on server with node runtime. Purpose, backend, logic. SSR affects only page rendering, not API routes. Even if every page is used client, API routes still run on the server. So remember, you can also render it in the server by removing this use client in your code. You disable server-side rendering, not server-side code. AI summary is triggered by your client, but executed on the server. So of course, the client will trigger the AI summary, but it is being executed on the server. Browser triggers request to Next.js API route. The Next.js API route to Firebase admin plus open API. Then it will store summary in Firestore, and then it will go back to Firebase admin and then to Next.js and to your browser. Browser request summary. Browser does not run OpenAI summarization. Example, await fetch /API /test -transcription -summary, inside method :post, closing semi-curly bracket, closing parenthesis, semicolon. That fetch function, that fetch open and close parenthesis calls a server, not the client. So these are React code. It calls the server or the Next.js API. How does Next.js replace Firebase functions? Firebase functions equals server code running on Google's Node.js runtime. So a Firebase function is also running on Node. It's just on Google's cloud. It's a server code running on Google. And Next.js API routes equals code running on Vercel or Node runtime. So it's in our case, it's actually running in Vercel, but it's still using Node under the hood. They are both Node programs. Feature, run secure backend logic, Firebase function, yes. Next.js API route, yes. Can use Firebase admin, Firebase function, yes. Next.js API route, yes. Receive webhooks, Firebase function, yes. Next.js API route, yes. Can write to Firestore, Firebase function, yes. Next.js API route, yes. Use Node.js server runtime, Firebase function, yes. Next.js API route, yes. Your backend is not Firebase functions because you did not deploy any function as an active webhook endpoint. You wrote your backend in API / ... inside Next.js. What is a runtime? A runtime is an environment where code executes with memory, CPU, network, file system. Like a kitchen where cooking happens. These are runtimes. Runtime, browser runtime, purpose, runs client, JS, React UI. Runtime, Node.js runtime, purpose, run backend, JS, Next.js API routes. Runtime, Firebase function runtime, purpose, run backend JS. Runtime, Vercel Edge runtime, purpose, run backend JS at edge locations. Runtime is not equal to client. Runtime is not equal to UI. Runtime simply means place where code executes. So what did you build? Client SPA React to server backend Next.js API routes to database Firestore to media server LiveKit SFU. You never use Firestore functions for your webhook or AI summaries, even though you thought you did. Final one sentence clarification. Your front end does an SSR, but your backend code still runs on Next.js runtime, where it calls Firebase admin and OpenAI just like Firebase functions would. Diagram, browser UI, fetch to Next.js API routes, node runtime to Firebase admin to Firestore to OpenAI summary. What you thought you deployed? You assume you deployed this kind of backend. Firebase Cloud Functions runs on Google Cloud. Deployed using Firebase deploy -- only functions. With a sample code like export.mywebhook equal functions.http.onRequest open and close parenthesis ... What you actually deployed, you deployed your Next.js API routes to Vercel. Those routes /API/webhook, the next /API/test -transcription-summary, the next /API/test-transcription. Those are the Next.js API routes to Vercel. It were compiled and deployed as backend serverless function by Vercel. So Vercel will run this like a backend, like this in TypeScript route.ts in API and /API/webhook. Sample line, export async function post, open and close parenthesis rec, open semi-curly, and next line you have this validated webhook, next line Firebase admin, next line OpenAI summary, then closing semi-curly bracket. Next.js API routes are backend functions when deployed. They are not stored in Firebase functions. They run on Vercel's function runtime Node.js. So when you deploy these routes, it actually became a backend function, kind of like compiled JavaScript. They are not stored in Firebase functions. They run on Vercel function runtime Node.js. Key clarification: you saw this in your deploy log /API/webhook. f/API/webhook. The F symbol in your Vercel logs in your deployment literally means serverless functions or backend execution. So that F means serverless function. That is your backend, just not a Firebase backend. Final simple truth, you did deploy backend code, but you deploy it to Vercel serverless function Next.js API routes, not to Firebase cloud functions. Therefore, you're not using Firebase functions for AI or webhooks. You're using Vercel serverless functions for AI or webhooks. You're using Firebase only for database best auth. Why this confuse you? Because the word function is also used here. Firebase functions equal backend on Google servers. Vercel functions Next.js API equal backend on Vercel servers. They are both backends but not the same runtime. How to prove which backend is running your webhook? Go to your LiveKit webhook target URL. It should look like https://livekit-front-end-xxx.vercel.app/api/webhook. If it were Firebase functions, it would look like https://us.central:/yours.function.net/webhook. So yeah, I see livekit-front-end.eau.vercel.app/doctor/invitation or the /API/ that app that /doctor/invitation or the /API/webhook. So that's the page or the component that actually these are talking about. Now your webhook target is on Vercel to Next.js backend. Summary in one line, you didn't deploy Firebase functions, you deployed your Next.js backend to Vercel, and Vercel is executing your AI plus webhook logic as serverless functions. If I deploy the Vercel serverless functions, do I expose LiveKit OpenAI credentials to the front end? No, if you store your keys correctly, they are never sent to the browser. How it should be done, which you did. You put secrets into Vercel Vercel_end vars next line next _public _asterisk is not used for secrets. You use them only inside server files like /API/webhook/route.ts and /API/token/route.ts and /API/test-transcription-summary. These execute on Vercel's backend runtime, not in the browser. What would expose your secret? If you put a secret as next_public_livekit_API_key, then next_public_OpenAI_API_key. Those are visible to the front end, which is bad. But you didn't do that. You used them server side inside API routes, which is safe. Your LiveKit tokens plus OpenAI calls are secure because browser sends a request, Vercel serverless functions read secret, response is returned, secret never sent. You're just using Vercel instead of Firebase functions for backend. Security works the same. Do you use Firebase functions in the full stack blog up? Short answer, no. That project used Node.js Express backend, deployed using Docker, not Firebase. Backend started via Node backend/src/app.js. Frontend was a separate Vite app. There's a folder named functions in your LiveKit app, but you never deployed, so I never used Firebase functions on the full stack blog app, and it has a separate front end, unlike my LiveKit app, which have an interconnected front and back end. You never deploy that folder as a Firebase Cloud functions. Why? There are no Firebase deploy dash dash only functions record. Index.js exists but no deployment config was used. Backend didn't use exports that underline equal functions that https that on request open and close parenthesis that live kit webhook target is universal, not Firebase Cloud functions. Proof inside your full stack blog repo, you deploy the backend with deploy dash backend.sh, deploy.ps1, docker file compose.yaml. This is Docker plus Node plus Express backend, not Firebase. Summary, feature, front end, LiveKit app, Next.js and Vercel, blog up, Vite slash React, feature backend, LiveKit app, Vercel serverless functions, blog up, Node Express, Docker, feature webhooks, LiveKit, Vercel API routes, blog up, Express routes, feature Firebase functions use, LiveKit app? No. Blog app? No. Summary feature secrets exposure. LiveKit app? No. Safe. Blog app? No. Safe. Finally, key takeaway. Deploying to Vercel functions does not expose your credentials. You just replace Firebase Cloud function with Vercel serverless functions as your backend. Your previous blog app also used a backend, but it was Docker or Express, not Firebase. Does Vercel serverless mean storing secrets in the front end? No. If you put a variable without next underscore public underscore, Vercel treats it as a backend only secret. These are safe and server-side only because they do not start with next underscore public underscore. Open AI underscore API underscore key, Firebase and next Firebase underscore private underscore key, next LiveKit underscore API underscore secret, next LiveKit underscore API underscore key, next LiveKit underscore webhook underscore secret. They're only readable inside server files such as app slash API slash asterisk slash route.js and pages slash API slash asterisk.js and server actions and any code that runs only on the backend. These run in serverless functions. These are public and exposed to the front end because they start with next underscore public underscore, next underscore public underscore livekit underscore URL, next underscore public and next underscore public underscore Firebase underscore API underscore key, and next underscore public underscore app underscore URL, etc. This is normal and required because the browser needs them to initialize SDKs. Firebase client key is allowed to be public. Google designed it that way. That's why you have next underscore public underscore Firebase underscore API underscore key. The real secret is the private key you kept server side. How serverless works in your app. Think of your app as having two sides. Part React pages, browser UI, where it runs, user's browser, can access secrets? No. Part API routes, slash API slash dot, where it runs, versus serverless, can access secrets? Yes. Part webhooks, where it runs, versus serverless, can access secrets? Yes. Part OpenAI slash LiveKit token generation, where it runs Vercel serverless. Can access secrets? Yes. So it actually the token generation of OpenAI and LiveKit are actually running in Vercel serverless, and it can actually access secrets that Vercel serverless. Your front end never talks directly using OpenAI LiveKit. Your front end never talks directly using OpenAI or LiveKit API secrets. It does not generate LiveKit tokens in the front end. You correctly generate them in backend routes. Easy way to remember, front end cannot hide secrets. Anything in the browser equal visible. Backend protects secrets. Anything in the serverless functions equal hidden. If it has next underscore public underscore, it is public on purpose. It doesn't. If it doesn't, it stays secret automatically. Did you use Firebase functions in your full stack blog app? You did not use Firebase functions. You use a standalone Node backend, Express in slash backend, a React or Vite frontend, Docker for deployment, optionally, no Firebase function anywhere in that repo. You only use Firebase client SDK on front end and Firebase admin SDK on server routes inside your LiveKit project. That means you use Firebase server side, but not Firebase functions. So you can use the Firebase server side by triggering Firebase admin SDK on your Next.js server route and having Firebase client SDK without actually using Firebase functions. So how to explain this? Vercel gives me Next.js API routes their own small servers called serverless functions. They can read private keys, but the browser cannot. Anything named next underscore public underscore is intentionally public for SDKs. So my LiveKit and AI calls happen only server side where the secrets are stored. Short version, front end equal UI only, backend equal serverless routes that protect secrets. How SPA single page apps connect everything? A full stack SPA like your LiveKit React plus Next.js app works like this. Browser React SPA, it will fetch Firebase or Firestore, and then data, which is it will request the next Firebase slash Firestore will send a request to functions slash webhook slash LiveKit API, and it will send events to LiveKit SFU via UDP slash quick. So the webhooks from Next.js will actually trigger the event of LiveKit SFU UDP or quick. SPAs change application design. Before SPA, PHP and Rails, server returns HTML per page. After SPA, client fetches JSON and then renders UI. Before SPA, SQL joins on server. After SPA, document fetches on client. Before SPA, multi-page routing. After SPA, client-side routing. Before SPA, round trips per page. After SPA, JSON fetch once. Cache in memory. So you avoid round trip because you cache that in your browser and your Firebase database or Fire data in your database. SPA makes document databases more natural because the browser wants one payload already in nested JSON that directly become JS objects. Oh my goodness. Sorry. Uh, React benefits from document locality. Where am I? Oh my god. So XPA makes document database more natural because the browser wants one payload already nested in nested JSON that directly becomes JS objects that React can render in a single pass. This is why the book says document database are closer to the data structure used by the application. React does Firestore, Firestore document to JS object to JSX render. SQL would have multiple queries, multiple round trips, multiple joins merging data manually. What does this paragraph mean? When representing many-to-one and many-to-many relationships, relational and document DB still use identifier. Relational calls it a foreign key. Document DB calls it a document reference. The reference is resolved at read time using joins or follow-up queries. This means both models still store user underscore ID colon code ABC123. The difference is how you resolve the ID. Relational DB, join user on document DB, firestore get doc parameter ref. In the relational DB, one server query with an optimizer. In document DB, several small client-side queries. In relational DB, fast for relational queries. In document DB, fast for hierarchical nested JSON. Relation to our previous message, it connects to locality, tail latency, TCP round trips, SPA behavior, load on SQL join engines, Firestore lack of joins, React consumption of full documents. If a SPA loads a dashboard and needs 6 Firestore doc, that means 6 TCP round trips. SQL could do it in one join, but with slower write locality, harder scaling, schema, rigidity. So you still store the same user ID ABCD123. But if you load the dashboard, you get a 6th round trip. But in SQL, you can actually do it in one join. That's why you can better synchronize your dashboard. And also that's why you get delay in your Firestore in your AI summaries because it needs to load 6 documents. But it's easy to scale in Firestore or in document database. Document DBs have not followed Codasil. Codasil equal old 1970s network database where you navigated pointers, parent to child, to next to parent. MongoDB or Firestore do not let you navigate pointer chains inside the single DB call. They simply say no joins, fetch more documents if you need them. How Firestore replicates document over TCP. Firestore uses gRPC HTTP/2 quick for future clients. Underneath all of this, always TCP or quick, never UDP. Firestore applications, document to binary proto, to gRPC frames, to HTTP/2 stream, to TCP segments to IP packets. Yes, this uses packet fragmentation. Is this happening in your LiveKit app? Yes, whenever your app does get doc, parameter doc ref. Firestore returns binary document, chunk into TCP segments, pack into IP packets. You don't see it, the OS handles it. Important clarification. Application rarely fragments versus Firestore document gets split into packets. These do not contradict. From TCP or IP illustrated, application rarely fragment because OS handles fragmentation. That means app don't manually split data. OS splits data into packets automatically. Firestore sending a document. Firestore to kernel to TCP segmentation to IP packets. Firestore is not manually splitting packets. The OS is. So both things are true. Application does not fragment. Packetization still happens. Your LiveKit app, UDP versus TCP. LiveKit media, video or audio, uses UDP or QUIC because low latency, tolerates packet loss real time. LiveKit chat or state or metadata, use WebSockets to TCP. LiveKit server handles signaling, join, room updates, participant metadata, chat messages. So yes, video equal UDP, chat equal TCP, Firestore equal TCP, Next.js API routes equal TCP. If I load JSON less than 1,200 bytes, what does that mean? 1,200 bytes equal typical quick packet size. A React Firestore call await get doc parameter docref. If the document is less than 1,200 bytes, often fits in one MTU to one round trip. For 2 kilobytes, split into 2 packets. 40 kilobytes, split into many packets. Is your sign-in page less than 1,200 bytes? Yes. Is your dashboard plus patient data less than 1,200 bytes? Probably no. Typical Firestore doc size in your app. Patient details 500 to 2,000 bytes. Consultation 1 to 20 kilobytes. Room metadata less than 1,000 bytes. What React code consumes whole document? Your app has examples. Look at patient/dashboard/page.tsx and doctor/dashboard/page.tsx. Typical React Firestore retrieval. Import parameter doc, get doc from app/live/firebase, semicolon, next line, const patient equal await get doc parameter doc, parameter db, code patients, patient ID, semicolon, then React uses it. Then return, open parenthesis, dashboard data equal patient data, closing parenthesis. React benefits from document locality because Firestore returns one binary blob. This becomes one JS object. React renders one tree. This is exactly what the book means, closer to the data structure used by the application. React components expect nested props, like this, less than consultation list, space consultations equal open and close semi-curly bracket. Inside this is patient.consultation, then // greater than to complete the kind of like the card component we did in the free concat, which fits Firestore nested documents perfectly. Final connections. Here is the full unification of all your topics. Full stack SPA to JSON documents to JS objects to React components. React wants nested objects. Firestore gives nested documents. This is why SPA frameworks love document DBs. Document DB locality to fewer disk pages to fewer TCP packets. Firestore document equal 1, blob equal 1, few TCP packets, low latency. SQL join equals scattered rows equal more packets. Query optimizer. SQL versus Firestore, no optimizer. SQL optimizer decides join order, uses B-trees, peak index test, while Firestore no joins and no optimizer because it's a document database. How client-side routing actually works. Client-side routing is not equal downloading HTML page. It means, step 1, browser loads the SPA bundle, JS plus CSS once. Your React or Next.js app is shipped as main.js, which is the React code, other chunks, i.e. components, CSS, maybe a pre-rendered HTML shell in Next.js. This bundle contains the router, Next-router, or React-router, etc. In our case, in LiveKit, we use Next.js. Step 2, router swap React components. Instead of navigating to a new slash page on the server, React runs router.push argument code slash patient slash dashboard, and React simply mounts the relevant component like this patient dashboard. So the HTML less than forward slash greater than. So you have this less than patient dashboard forward slash greater than. No HTML navigation, no page reload. Everything happens inside one.js runtime, already running in memory. So it's just in one.js runtime that is loaded once, already running in the browser's memory. Does SPA fetch everything at once? Not exactly. SPA behavior in real world. What loads on first load? Core.js bundles, CSS, router, main UI shelf. When does more load? When you visit a route, React easy loads the component code. What loads at first load? Often some initial Firebase Firestore data. When does more load? Deeper pages load more data on demand. So actually, React also lazy load some of the route when you visit a route, some of the component code. And another is, what does load and first load? LiveKit JS SDK. When does you do more load? When you enter a room. So yes, there is caching, but not the whole app at once. Browser stores it in JS heap runtime memory. So that's kind of like what you see is IndexedDB. V8 engine caches, HTTP cache on disk. This is all user space, not OS kernel memory. So it's on your browser and user space application, not on OS kernel memory. You save it not in the Firestore memory, but in the user space. Second, several small client-side queries. This was confusing you, so here's the correct meaning. In a SPA, a page is not built from one big JSON blob. React pages equal many small Firestore reads. So it's not from a single lab, but rather a many small Firestore reads. Example from your LiveKit dashboard, /doctor/dashboard will load doctor profile, load upcoming consultations, load invitation tokens, load role info, load room metadata. Those are separate Firestore calls, each returning a small JSON document. These parallel our earlier topic on fanout. Instead of one big SQL join, you have many document reads. This can increase latency like RPC fanout unless the database has locality. Firestore gets away with it because of document level locality. What is a binary blob? A binary blob equal row bytes stored without structure. Examples: images, audio chunks, FFmpeg HLS segments, protobuf messages, WebRTC encoded video frames. A blob is not JSON, it's just opaque bytes. How it connects OS treat blobs as byte arrays in memory or files. TCP or IP, TCP breaks blobs into packets automatically. Your LiveKit app, LiveKit uses SRTP/UDP to send binary AV frames. JSON to JavaScript object. When your React code receives Firestore JSON, like name, John, age 30, it is literally just text before parsing. /name, /John, /age, /30. Then Firestore SDK runs a JSON parser, user space JS code, JSON.parse, JSON string. Now it become real JS. Name code John, age 30. Why both text and object are correct. Over the wire, text bytes. In browser, JS object in V8 heap memory. This is not OS level parsing, it's user space JS. Firestore and TCP. Firestore uses gRPC over HTTP/2, which uses TCP underneath. TCP automatically fragments anything greater MTU, 1 to 100 bytes for quick, 500 for Ethernet. So yes, your Firestore documents split into packets. Your video via LiveKit sent using UDP or quick, not TCP. Your app uses feature Firestore reader writes protocol gRPC, HTTP/2 TCP. Feature LiveKit video WebRTC, UDP, quick SCTP, and then fallback as TCP. LiveKit chat, STP, SCTP over DTLS, which is UDP. SSR fetches, HTTP/2 or HTTP 1.1 for TCP. Firestore document locality. If a single dashboard needs 5 related documents, Firestore store documents close together on disk if they share a collection path, like this /user /open semi-curly ID close semi-curly bracket. Then next line /user /open semi-curly ID close semi-curly bracket /consultation /open semi-curly bracket CID closing semi-curly bracket. Next line /users /open semi-curly bracket ID open closing semi-curly bracket /token opening semi-curly bracket TID closing semi-curly bracket. This reduces tail latency. 2 related docs live near each other. This is what better performance due to locality meant. How gRPC connects to OS, TCP or IP, DSA. gRPC is just data structures, protobuf structs, encoded to binary message, sent via TCP streams, scheduled by OS, flow controlled by TCP, parsed back into structs. It uses DSA concepts, structs, trees, graphs, TCP IP illustrated concept, segmentation, congestion control, OS concept, threads, syscall buffer. So all your previous message connect through the full stack. React to Firestore SDK to protobuf to gRPC to HTTP/2 to TCP to IP to NIC to router. Your LiveKit patient dashboard annotated. Below is a conceptual annotation based exactly on app/patient/dashboard/page.tsx, where TCP happens. Firestore call inside your React component. Next, the JS server-side API routes. SSR data loading in get server-side props. Auth calls to Firebase auth. All to gRPC/HTTP over TCP. Where JSON to JS happens, Firestore SDK receive JSON documents, decodes them in user space JavaScript. It puts them into the React state hooks. Example, const doc equal await get doc rep semicolon TCP response. Next line set user doc.data open close parenthesis semicolon, which mean JSON parse to JS object where React renders anytime. Set state open and close parenthesis .NET is called after Firestore data arrives, where Firestore locally helps. If your documents are structured like /patient/open semi-curly bracket UID close and semi-curly bracket, next line /patient/open semi-curly UID closing semi-curly /session/SID, next line /patient/ open semi-curly bracket UID, closing semi-curly bracket slash summaries slash open semi-curly bracket mid, closing semi-curly. Firestore can read multiple related documents with less tail latency because they live in the same physical storage region. Why your LiveKit app makes many small Firestore reads. This app uses Firebase Auth plus Firebase on Snapshot listeners plus Next.js SPA client routing. That combination naturally produces small reads because first, on Snapshot creates live listeners. This means each listener equal one read when attached, plus one read on every change, plus listen heartbeat traffic, plus metadata sync. You have many listeners: dashboard summary listener, consultation listener A, consultation listener B, user document reads for email lookups, room creation rights, patient registration listeners, invitation listeners, doctor dashboard listeners, room listener, live kit linking. These attach at navigation time, not reload time. Second, how an SPA Next.js app router loads and send requests. Your app is a partial SPA. Routing is equal client side Next.js use client. Fetching equal client side React hooks. Firestore equal real-time listeners. Pages equal stream. What happens on first load? Three phases. Phase A, static or server parts first. The browser loads pages, page.tsx HTML shell, layout.tsx, global JS bundle, Firebase SDK bundle, 100 to 300 kilobytes, LiveKit SDK bundle, 200 to 500 kilobytes, CSS, this is one big cost up front, but happens only at once. Phase B, client hydration, once JS loads, React execute this. Use effect, on auth state change, it triggers Firebase auth internals, reads 1 kilobyte, redirect logic, router that replace, no network, purely SPA. Phase C, Firestore listeners attach. When dashboard mounts, on snapshot call dash summaries and on snapshot consultations by creator and on snapshot consultations visible to user. Each fires one initial read, then streams update, triggers additional reads for metadata. Total small reads, 3 to 12 depending on user data size. Exact bytes, what each action cost. These numbers are based on known Firebase Firestore wire formats. First page load, component, Next.js JavaScript chunk, typical size 100 to 300 kilobytes, and Firebase Auth SDK 20 to 80 kilobytes, and Firebase Firestore SDK 100 to 200 kilobytes, and LiveKit Client SDK 200 to 500 kilobytes, and React Hydration metadata 10 to 60 kilobytes. Total 400 kilobytes to 1.1 millibytes. One time until browser cache invalidates. When user signs in, Firebase Auth does token refresh request 1 to 4 kilobytes, user metadata fetch from IDP 1 to 3 kilobytes, total 3 to 7 kilobytes. Letter C, dashboard load. Firestore listeners. Each listener attach 1 to 3 kilobytes initial document metadata, 0.5 to 2 kilobytes per document returned. If user has 20 summaries, 5 consultations, then call summaries listener, 1 listen start plus 20 docs equal 20 to 50 kilobytes. Consultation listeners, 2 listeners, 1 to 3 KB plus docs 5 to 10 KB. Total dashboard read cost 25 to 60 kilobyte on first load. Creating a room, this part uses Firestore set doc. 1 write plus 1 document read for metadata equal 1 to 3 kilobyte. Second, CSR navigation to /create -room and room. Client loads page code 10 to 40 kilobyte JS chunk. Third, Firestore room listener attaches 1 to 2 kilobytes initial read, total 15 to 45 kilobyte. In-room LiveKit usage, mostly WebRTC, stance-turn handshake, and SDR, and LiveKit signaling 2 to 5 kilobytes to join, and WebRTC media not relevant to Firestore cost. No Firestore reads unless room metadata updates, patient/doctor linking listener triggers, total Firestore less than 3 kilobytes. WebRTC traffic is separate. Why SPA routing makes you confused? You're thinking, if I didn't load a new page, why did Firestore read again? Because SPA routing does not reload the page, but React unmounts old components and mount new ones. And each mounted component attaches new Firestore on snapshot listener. So that's the key, the mount and unmount and attach a Firestore listener. SPA routing equal new component tree equal new listeners equal new reads. How all this connects to your previous questions? Earlier you asked, is the database more complex than TCP/IP illustrated? Here you see why Firestore real-time system is a distributed system layered over HTTP/2 streams. Complexity is hidden but massive. Does SPA cause many requests? Yes, in this project, all the client-side listeners reactively requery data. Why am I confused by SPA versus backend? Because Firebase plus React mixes authentication, real-time queries, client routing, server actions, next API routes, Firestore rules, LiveKit callbacks into a single flow. This app is unusually complex for an SPA. Extremely clear summary. What generates the many small Firestore reads? Firebase auth, Firestore on snapshot listeners, email lookup via getDoc, mount/unmount from SPA routing, debounce updates, real-time presence/metadata sync. Does SPA make more requests? SPA makes more Firestore connections, but fewer HTML plus JS reloads. What are the byte costs? Initial load 400 kilobyte to 1.1 MB. Login 3 to 7 kilobytes. Dashboard 25 to 60 kilobytes. Creating a room 15 to 45 kilobytes. In-call Firestore less than 3 kilobytes. LiveKit uses WebRTC.